Welcome student in our today's session of laws of motion from science part 1. Student, today we are going to learn equation describing the relation between velocity and time. Suppose there is a object which is in motion along a straight line with initial velocity u, final velocity v and in time t. It covers with acceleration a, the displacement is s. Student, for that purpose we draw a graph which is velocity time graph. See here, it is the graph. That graph is called velocity time graph. Student, what that graph shows? That graph shows the change in velocity in time t of a uniformly accelerated object. The object starts from point D in the graph, see, with velocity u. Its velocity keep on increasing and the object reaches at point B after time t. So from the graph, student, initial velocity OD is equal to u and final velocity OC is equal to v. So put that value like that. The initial velocity of an object u is equal to OD and the final velocity of an object v is equal to OC. In time t, that is OE, where it that time t, OE, that is OE time t. Let us take, student, how to solve that equation. We know that the acceleration a, change in velocity upon time. Change in velocity is nothing but object starting from initial velocity and goes to the final velocity. So final velocity minus initial velocity upon time. Which is the final and initial velocity? C. Final velocity OC. Put that here. Minus initial velocity OD. Put that here upon time. So CD is equal to A into T. How we get CD here? So student, OC minus OD is equal to CD. How? Let us take on the graph. See here, OC, that OC minus OD, what remain? CD. So we can put it here. That is the equation number 1. Student, now draw a parallel line to y-axis. That is the y-axis. Draw a parallel line from point B towards the x-axis, which passing through the point E on the x-axis. Then draw a parallel line for the x-axis. Draw a parallel line for the x-axis from the point D. Already we draw it, which passes through the point A. Let us take, student, from the graph, that is, what is BE is equal to? Yes, BE is equal to AE plus AB. We can write it here. BE is equal to AB plus AE. Student, already we know that V is equal to, that is, final velocity means what? CD plus OD. Student, in the graph, CD is equal to AB. Clear? OD is equal to AE. Only I write it here. Therefore, student, V is equal to, what is CD? C. The first equation, CD is 80. Put that value plus OD. What is OD? Initial velocity U. Put that U here. So we get V is equal to U plus 80 from equation 1. I rewrite and rearrange equation and write V is equal to U plus 80. That is the first equation which describes describing the relation between velocity and time. Student, let us turn toward the next equation. Equation describing the relation between displacement and time. For that purpose, student, once again we use the same graph. See, student, let us suppose an object in uniform acceleration a and it has covered the distance s with time t. From the graph, the distance covered by the object during time t is given by an area quadrangle DOEB. Let us find out here DOEB. So student, that is the quadrangle DOEB. That quadrangle gives that acceleration. So therefore, we can write S is the displacement is equal to area of quadrangle, which is quadrangle DOEB. Student, we know that area of quadrangle DOEB is comprises of or consists of one triangle and one rectangle. So their area is of two areas, which is that triangle and rectangle. So we can write here area of rectangle DOEA. Where is DOEA? Plus area of triangle DAB. Where is DAB? So what is the rectangle area? What is the formula of rectangle area? That is length into breadth. So AE into OE is the length into breadth. Where is AE into OE? Let us take next the area of triangle DAB. So 1/2 into base into height, that is the formula of area of triangle. AB into DA. AB height height into base, that is AD. So we write it here. Now we know that student AE is equal to U. Where is AE? AE is equal to U. Next OE is equal to T. OE is equal to T. OE is equal to TA. OE is equal to TA. So both have the value T. AB is equal to AT. Therefore we can write that AB is equal to AT. A, where is B? That is B. AB is equal to AT because AB is equal to CD. Already in equation 1 we solve it. CD is equal to AT. Next student, therefore displacement S is equal to, put that values AE into OE, that is U into T plus 1/2 as it is. 1/2 as it is. What is AB? AB is AT into T. So we can write S is equal to UT plus 1/2 AT square, that is Newton's second equation. Now student, we are going to learn the next equation, that is equation describing the relation between displacement and velocity. Let us take student the next, last and third equation. Equation describing the relation between displacement and velocity. Student, for that purpose we using the same graph. Student, we have already learned that to determine the distance covered by an object in time t, the area of quadrangle DOEB is. So DOEB is a trapezium. What is that area? That is nothing but the trapezium. So we can use the formula for its area. Let us take. Therefore, S is equal to area of trapezium DOEB. Therefore, S is equal to, what is the formula of area of trapezium? That is 1/2 into sum of length of parallel sides into distance between the parallel sides. So let us take that parallel side. S is equal to 1/2 into OD plus BE into OE. Student, let us take which is that OD plus BE. Sum of length of parallel sides. OD plus BE. OD plus BE. Parallel sides length into OE. OE. What is that? Distance between parallel sides. So that distance is OE. Now student, but we know that OD is equal to U, then BE is equal to V, and OE is equal to T. Put that values. Therefore, S is equal to 1/2 OD is U plus BE is V into OE is T. But student, A, acceleration is equal to change in velocity. So, acceleration is equal to V minus U upon T. Therefore, T is equal to V minus U upon A. That is the equation number 2. And it is the equation number 1. From both equations, student, we can write therefore S is equal to 1/2 into U plus V into V minus U upon A. Therefore, S is equal to V plus U into V minus U upon 2A. That is 2 into A, 2A. V plus U as it is, V minus U as it is. What I only rearrange that equation. Let us take next 2AS. What? 2AS. Let us take next 2A into S as it is equal to V plus U into V minus U is equal to V square minus U square. So student, take that final velocity V square is equal to U square plus 2AS. That is the final and third equation of Newton's third equation of motion. So we can write it here, Newton's third equation of motion. So see how we solved it. Trapezium, formula of trapezium, their values. So that is all about today's session. In the next video, student, we are going to learn the numericals or examples from the exercises. Okay, thank you, student.